All right, so this is 3.2, solving absolute value inequalities, and we're going to do 15 as well as 19 and 20. So let's start with a basic absolute value inequality. We notice here the absolute value is already isolated. We want to make sure the absolute value is isolated before we start solving. So I'm going to split this into two inequalities. The first inequality, we're going to drop the inequality, or drop the absolute value sign and write the inequality exactly as it appears. For the second inequality, again, I'm going to drop the absolute value sign. Make sure you leave what's inside the absolute value exactly the same. That doesn't change at all, but we need to change both of these. The absolute value disappears, the inequality symbol changes, and the 9 becomes negative. So we have two inequalities. We're going to solve both. So we get 2x is less than 8, x is less than 4. 2x is greater than negative 10, x is greater than negative 5. So in this solution, x is less than 4, x is greater than negative 5. Let's go ahead and see what that looks like on a number line. All right, if x is less than 4, I'm going to do an open circle here, and I know less than would be this way. X is greater than negative 5 as well, so I need to also include that. Greater than is this way. If x is less than 4 and it's greater than negative 5, that means all of these values between here are all solutions to this problem. Okay, let's look at one that's a little more challenging. Let's look at number 19. All right, now notice on this problem, the absolute value is not isolated as it was on number 15. So let's look at how can we isolate the absolute value here. We need to add 12 to both sides in order to get that absolute value by itself. So I'm going to isolate it by adding 12 to both sides. Okay, then I'm ready to do the same steps I did here, which is to split my inequality into two problems. I'm going to drop the absolute value sign. The first inequality will be exactly the same, just without the absolute value. The second inequality, we need to change the inequality symbol, and we need to change the 6 to a negative 6. So this gives me x is greater than or equal to 3, x is less than or equal to negative 3. Okay, now let's see if we can graph this. We have greater than or equal to positive 3, less than or equal to, so close circle, negative 3. All right, notice how this problem, we had that x was greater than negative 5 and less than 4. That gave us this solution region that faced inwards. Over here, we have greater than 3, less than negative 3. Our solution region is pointing away from each other. All right, number 20 is another absolute value problem where the absolute value has not been isolated for you, so we need to do that first. We need to first add this 3 over to this side. So I'm going to add 3, and that gives me negative 9. Then we need to get rid of this negative 9. If you have a negative 9 absolute value, the operation that's happening here is actually multiplication. So that means I need to divide by negative 9. Absolute value of x minus 2. I have now divided by a negative number. That switches the inequality sign. And we're going to split this into two inequalities. X minus 2 is less than 1. My second inequality will be x minus 2 is switch the inequality symbol, switch the 1 to a negative 1, and solve. So x is less than 3, x is greater than positive 1. So I have x is less than 3, x is greater than 1, Okay, this is pointing.
Bruno Sanchez, please report to the curriculum office. Bruno Sanchez, please report to the curriculum office.
Alright, this one is pointing in towards each other, similar to how number 15 was. And our solution is given both algebraically and graphically.